Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Very important concept today, so you need to watch the complete video. Have you heard about the problems of upstream and downstream motion of boats? Very important concept right from class 10th onwards, where you face it in linear equations in two variables and quadratic equations, and these concepts are unavoidable in the Olympiads, in the quantitative aptitude exams, placement exams, CAT, MAT, railways, banking, wherever you find quantitative aptitude, upstream, downstream motion of boats is always there. So I'm going to simplify a very important concept using 6 to 7 minutes of your time, and if you watch this and apply this, I tell you the concept is going to consume only 5 to 6 seconds to get solved. Whereas when you follow the traditional method of making the linear equations and quadratic equations, it will take 4 to 5 minutes. So 4 to 5 minutes to 4 to 5 seconds. That's what is the intention of this video, finding the speed in still water and the speed of stream. So the stream is moving at a particular speed, right? So we want to find that speed, and if the speed of stream is considered as 0, then the speed of boat in still water, that means when the stream is not moving, how much is that speed? We need to find both of them. Okay, short trick. This is a part of chapter number 1 of our quantitative aptitude book and volume 2, and this is entitled Master Speed and Time Problems. We are going to indeed master it. And if you want a compilation of all these short tricks at one place, as a PDF, as an ebook of short tricks, then you can send me a message on WhatsApp. This is the WhatsApp number 9896369963. Go for it now, friends. It is a treasure of knowledge. So friends, what is the concept involved in the trick? Let's understand the concept. So we have a particular stream, right? And this river is flowing at some speed. So let's consider that the speed of this stream is y kilometer per hour. And in this stream we have a boat which is moving, and this boat is moving with a speed, right? Its own speed. That is called speed in still water. That is x kmph. Now one basic thing to understand here is x, the speed of boat, has to be greater than the speed of stream. Otherwise, if x is less and the stream is flowing opposite to the direction of boat, the boat will not be able to move forward. Therefore, x is always greater than y. Speed of boat in still water is always greater than the speed of stream. Having understood this, now we should understand the downstream and the upstream motion of boat. See, whenever the boat is moving downstream, speed downstreams is given by, see, downstream means flowing along with the flow of the river. That means the same direction. So what will happen if you are cycling and wind is pushing you from the backside? Your speed is going to increase, right? So whenever you have to calculate speed downstreams, let's write it as d, you add x and y, and whenever you are going upstreams, what do you mean by upstreams? Upstreams means the wind is blowing in opposite direction, so you are trying to force through the wind, or the river is flowing in a particular direction and you are coming opposite to that. That is called upstream. How do you find the speed upstreams? It is x minus y. Now if in the question you are given the downstream speed and the upstream speed, that means when you are moving along with the flow of the river and when you are moving opposite to the flow of river, those two speeds, if they are given to you, you can find the value of x, which is the speed of boat in still water, and y, which is the speed of stream, directly without making equations. So if you want to find x, you will just take downstream speed plus upstream speed and divide it by 2, and whenever you have to find the speed of stream, you will do downstream speed minus upstream speed by 2. Now this is the shortest method of solving this question. So what should be given in the question? The downstream and the upstream speeds of the boat should be given. Let's try it on one question so that we can understand and apply the concept. Here you can see there is a motor boat which goes downstream. So we have D given to us with a speed of 30 kmph. So D is 30 kmph and upstream. So upstream speed U is 26 kmph. And now we need to calculate both the things, that is speed in still water and speed of the river current. So to find the speed in still water, I'll write SW still water, we just need to add these two, 30 plus 26 and divided by 2. So what will this become? This is 56 by 2, which is 28 km per hour is the speed in still water. So the boat, when the water is still, it is having a speed of 28. Likewise, speed of stream, how much is that? Now in place of plus you need to write the minus. So this becomes 4 and 4 by 2 is 2 km per hour, and these are the two answers. See, add, divide by 2, you get the speed of boat in still water. Subtract, divide by 2, you get the speed of stream. Likewise, if you see this question, downstream this is D, upstream this is U. So we need to find the two things. So speed in still water, 17 plus 11 by 2. Speed of stream, subtract 17 minus 11 by 2. This is 28 by 2 and this is 6 by 2. That means 14 km per hour is the speed of boat in still water and 3 km per hour is the speed of stream or the speed of current. See how quickly we are getting to the answer now. Let's solve it using the same approach. What will be the speed in still water and speed of stream? Add and divide by 2. So this is downstream 22.5, add upstream 19.5 and divide by 2. What is this? This is 22 plus 1 is 23, 23 plus 19 is 42. So 42 by 2, it is 21 km per hour, and when you subtract 22.5 and 19.5 and divide that by 2, you will get, this is 3, right? So 3 by 2, you will get 1.5 km per hour is the speed of stream. Finding more easier now. Let's see one more. Downstream, so this is D. Upstream, so this is U. So the first speed, that is speed in still water, is 21 plus 17 by 2, and speed of stream will be 21 minus 17 by 2. This is pretty easy. This is 38 by 2, which is 19 kmph, and this one is 4 by 2, that is 2 kmph. Now, how much time are you going to take to solve this question? I think you will yourself say 10 seconds. And that's what is the intention of bringing out all these short tricks for you. So friends, apply this trick and you need to let me know in the comments whether these tricks are working for you or not. Okay? And share it with your friends. That is very important, Let everybody know how beautiful these short tricks can be and how much time they can save for you. So I'll wait for your comments here whether this trick is working for you or not. Do subscribe the channel and click the bell shaped icon so that you keep on getting all the notifications of future uploads on the channel. All the best.